Hi everyone, welcome to our lesson on residual plots. Sorry that I can't be there in person, but this video should show you everything you need to know. Alright, so you can see here I've got a list up of everything that you should already know for this topic. I'm not going to go through them all now, but you should be able to do all of these things that I have listed confidently. That sort of means that you're up to date. If not, you've got some work to do. And today, these are the two things that we will be doing. By the end of this lesson, you should be able to explain what a residual plot is and be able to construct one. So let's get started. Residual plot. So a residual plot is a graph, and we use it to decide if the data that we're looking at is a linear model or if it's non-linear. So the way that, that's this bit of information here, the way that we tell that from the residual plot. So if you can see a clear pattern in the residual plot, it means that the data is not linear. And that means that if there's no clear pattern, then your data is linear. So this is what we'll see. So what happens when the data isn't linear? So a graph like this, we can see that it probably has more of an, this is a very bad line, exponential trend. So it still has a strong correlation. So if we were to calculate just our R value and our R squared, it would still show that it has a strong correlation, but it's not actually linear. So we can see here that an exponential model actually would be more appropriate. And this is important when it comes to us making predictions like we have been with the least squares regression. So if your data is not linear, you wouldn't use that model because it wouldn't give you accurate results. So so our first point is to look at our R and R squared. If they can't help us determine if the data is linear, that's when we look at residuals. So really you should be looking at all three of these things, especially when it comes to your data that you'll be collecting for your investigation. So what is a residual point? So the value basically is, say these points here are from our data and we've put in a line of best fit. So the residual point is this gap from the predicted value that we get from your line of best fit and your actual data point. And it's this difference here that is your residual point. That's the value. So each data point, if you have 12 data points in your data, you will have 12 residual points. So it's that vertical distance. You can get positive residuals and negative residuals. So this gap here, anything that's going to be above the line is going to be a positive residual. Any data points that are below the line are going to be a negative residual. And sometimes we call them errors because basically it's the difference between your data point and the regression line. So sometimes we can call them error points. It doesn't mean that there's anything wrong with the analysis. It just means that there's a difference between the data we collected and then the predicted model. We usually call them residuals more than errors in our questions. And the way we calculate them. So we calculate a residual by using this little equation here. So your residual point would be your Y value observed. So that's your point that you actually got from your data or the data that they gave you. And you're going to take it away from the predicted Y value, which is from your line of best fit. So you're basically taking your Y data value and you're subtracting it from your Y line of best fit value. And when you get a residual plot, it'll look something like this. So you plot it against your X values that you have in your original data set. So usually we do our X values in list 1 and we have our Y values in list 2 and then we graph them. So what to make our residual plot, what we do is we still have our x values in list 1, but then we're graphing them against these residual points that we get. So you'll get a graph that will look something like this. And I can see here that in this data set, there is quite a clear pattern. You can see that it sort of makes a U shape. So this would be indicating to me that this data set is nonlinear, because I can see a clear pattern there. It's not like evenly distributed all over the place. All right, let's do an example and then hopefully you can do your own ones. All right, this is my data set. I haven't given you any context to the question, but basically these are my x values, these are my y values, and I want to find my least squares regression line equation. The way I do that is I get my trusty graphics calculator and I put in all my values. So I always do x values list 1, y values list 2, and then I go into, let's have a look, I go into calculate, F3, F1, and then F1 again, and you can see here I have my A value and my B value, so I can now sub these into my model. So that's where B is going to go, that's where A is going to go. So my least squares regression line is this model here. So y equals 1.6x minus 0.23. Now what I want to do is I want to calculate my residuals. So if I this is what it would look like graphed, so I can do that on my graphics calculator. You could see what the graph looks like, and I have 5 points. I've got 1, 2, 3, 4, 5, and I am measuring, this is the values, these are my residuals, this is the gap here. So the way I like to do it by hand is to make up a table. So I've got my x value here, and then I have my y value that I observed, so you can see that came from my first data point, and then I've got my equation that we just got, and I'm going to sub in what my predicted y value would be if I had for my x point. So you can see I've subbed in x equals 3, and my predicted my predicted y value is here is 4.6. So I can see that if I do 7 take away 4.6, I get a residual of 2.4. Then I'm going to go and do that for my other 4 data points. So here my x value was 4 and my observed value was 4. I'm going to sub in my x value here and I get 6.21. So now I'm going to have a negative residual. So 4 take away 6.21 is minus 2.21. I'm going to do the same thing here. So again, using my x value of 6, I predicted, my data showed that my y value was 10, but my predicted from my least squares regression line is 9.43. I'm going to do that for this data point. So I got negative 3.27, and then my last one, I got 2.51. So you can see here that I have my x values, so 3, 4, 6, 9, and 11, just like these x values up here. And then I have my 5 residual points that I just calculated. And if I was to graph it here, all right, you can see that I've got my 5 data points here, and there's no clear pattern. So because there's no clear pattern, we would say that this model is linear. All right, now I'm going to show you how to actually graph this residual plot on your graphics calculator, because it will be a lot quicker for you. So you list your values into list 1 and into list 2 like we just did. I did that on the graphics calculator before, so we do all of that the same. And then you press shift menu. So I will show you on this little example here, so have a watch here. So I'm going to press shift and then menu, and you only have to do this once to set it up. and then we're going to go down to residuals, and I'm going to click list 3. So what that means is in a minute, I'm going to get my residual points. My graphics calculator is going to calculate them, and they're going to come up in list 3. So that was the page, what it looked like. So remember, I went down to residuals, put it in as list 3. So you only have to do this once to set up your graphics calculator, and then you don't have to do this step again. So then what we do is, sorry about that, I just had to pause the video. So now I'll show you how we actually get these values up. So let's have a watch of this little video here. So you get them in, you calculate, you go to this page as normal, and when you press exit, these automatically calculate. So then you have all your residuals right here. So all you need to do to get your residuals, now that we've set up your calculator, is you just go through and get to this page, which we've been using a lot, so you should know how to get there. And then the moment you press exit back to this list, it'll come up with your residual points. Then we want to know how to actually graph them. So what we're going to do is we're going to set up, we already have graph 1. So when you guys go into graph and then graph 1, that's already set up to graph your list 1 against your list 2. So that shows your data graph. We're going to set up graph 2 that it will always do your list 1, so your X values, against list 3, your residuals. So then your graphics calculator will be programmed to plot, graph 2 will be your residual plot. So I will quickly show you how to do that on here. So we go graph, we go F6 set, we go, instead of graph 1, we're going graph 2. We still want to scatter plot, but we want to change our Y list to list 3. So now that is set up, and then if we go graph 2, we can see that we have a residual plot right there. So here on the PowerPoint, I have written down all the instructions for how to set up your residuals and how to graph it. So if you want to come back to this, you can definitely do that. So what I would like you guys to do now is to have a go at question 1, 2, 4, and 6 in this double lesson. So these should be completed in the double. If they're not, you need to make sure you have done them before our lesson next Thursday, because we have a student free day on Monday. Let me know if you have any questions, and I can definitely help you out. Happy Friday. Bye.